Hey folks, my name is Tirth. I'm a Senior Solutions Architect here at AWS. Today I'm going to talk about AWS Edge Networking Services and how you can use them to improve performance and security of your current applications. So let's dive in. So I want to talk about AWS Global Footprint. What really improves availability and performance is connecting your users to servers that are close to them. This cuts down travel time of a packet on the internet and can improve performance. Having access to hundreds of different servers improves availability because in case of a failure of a single server, your users can be routed to other available servers globally. Your user base may be global or it may be local, but in order to deliver best user experience, you need fast and secure network. This is why AWS continues to invest in our global network, adding more regions and edge locations all the time. We have 24 different regions and 77 availability zones. AWS has more than 225 edge locations, also known as points of presence, across 45 different countries, and they are connected via private network backbone. So we have a variety of edge services for different scenarios. We'll talk about what each of these services does and how you can implement them in your current architecture to start getting benefits that these services provide. So really, AWS Edge Networking Services really target two pillars of a great user experience: improving performance and availability and enhancing security posture of your application. So I want to talk about services that really target the performance improvement, and then we'll talk about edge networking security services. So Route 53 is the first service that I want to talk about because what's the first thing that happens when you connect to an application or a website? You use DNS to resolve the domain name to an IP address. Route 53 is a highly available and performant DNS service running globally. In addition to 100% uptime SLA, Route 53 provides advanced routing options such as routing your users to AWS services that are lower in latency and geographically closer. It also supports DNSSEC, which is oftentimes a requirement for security-sensitive workloads. Next, I want to talk about Amazon CloudFront. CloudFront is used as a major pillar to improve performance of any applications, be it dynamic API traffic, media workflows, or static content delivery. By using CloudFront, you allow your end users to connect to hundreds of servers across the globe that are close to them. Geo-proximity combined with Amazon's private fiber network provides your end users with the lowest latency access to your content. Having tiered cache servers improve cache hit ratio of your content, and it reduces load on your origin servers. So let's dive a little deeper into CloudFront. So there are lots of things that are baked into CloudFront that improve performance. For example, CloudFront has implemented TCP optimizations to speed up the TCP connection process and improve the congestion control. The TCP optimizations such as TCP Fast Open and BBR improves latency and throughput for last mile delivery. As a user, you also can perform a variety of customizations to boost your application's performance even more. CloudFront can automatically compress your content with gzip and Brotli compression. You can configure your CloudFront distribution to cache media assets for an extended period of time using Origin Shield. Let's look into these optimizations a bit more. So with latest CloudFront cache and origin request policies, you don't need to choose between the option of forwarding different request components such as headers and keeping your cache hit ratio high. CloudFront allows you to customize your cache key so that you can forward headers like user agent to your origin and not include that into your cache key. This essentially keeps your cache hit ratio high and improves performance of your application. You can also forward all or selected query strings and cookies under origin request policies if you are varying your origin response based on those things. And cookies and query strings are generally used for dynamic content that you generate for your users or your applications. So what is AWS doing under the hood to improve cache-hit ratio? CloudFront has a number of cities around the world in which we have multiple POPs deployed. Currently, these POPs potentially all serve the same accounts and same distributions. In some cases, this is not the optimal use of our infrastructure. POPs, also known as points of presence, in the same city have network topology and latency variance of just a couple of milliseconds. We could improve cache width and efficiency by portioning distributions across this regional footprint. DCP also stands for Dynamic Content Placement. We'll use distribution characteristics such as request rate, catalog size to shard distributions across POPs in a city. So essentially, different POPs will have data for different distributions. This will gain up to 90% additional cache width per POP in a given city. So I wanted to talk about Origin Shield. Origin Shield is a feature of CloudFront that reduces the amount of requests going back to your origin, which improves performance because requests now do not have to travel all the way back to the origin. It also reduces the cost of running more resources on your origin now because your request load to your origin is less because now you are serving most of your traffic from Origin Shield. So next up is Lambda at the Edge. Lambda at the Edge is a feature of CloudFront that supports computing at the edge. With Lambda at the Edge, you are moving serverless compute closer to your users and can essentially perform any type of customizations to your CloudFront requests and responses. Most common use cases we see around Lambda at the Edge are authentication at the edge, request and response manipulation, A/B testing for new feature launches, and we see customers build new solutions using Lambda at the Edge every day. Next, I wanted to talk about AWS Global Accelerator. Global Accelerator is a networking service that sends your users traffic through AWS's global network infrastructure that improves your internet user experience by up to 60%. So what are some of the key features of AWS Global Accelerator? First, your accelerator's IP addresses are fixed for the lifetime of your accelerator. They are not shared with other customers and you can enter them in firewalls and DNS records. There are also some legacy devices that don't even support DNS servers, so you can use Global Accelerator's IPs directly for that. Second, by ingressing your users' traffic into the nearest edge location, you bypass a lot of the global internet congestion and keep your packet loss, jitter, and latencies consistently low. This will result in performance improvements of up to 60%. Third, AWS Global Accelerator can perform a worldwide failover away from an unhealthy endpoint in less than 30 seconds. And that is independent of DNS TTL or Internet Service Provider resolvers that may not be respecting your DNS TTL. So in that case, you can utilize Global Accelerator's failover mechanism. Fourth, AWS Global Accelerator allows you to add or expand multiple AWS regions behind a single accelerator. Or you can also migrate traffic from one region to another with using Global Accelerator and without ever changing your public IPs and DNS records that may be user-facing. And lastly, all accelerators are protected by default from distributed denial of service using AWS Shield. So why does all this matter? The internet rarely goes in a straight line, and it can take many networks for users to reach your app. If you do the math for the common fiber types used to build the internet, you will find that you can only travel about 100 kilometers or 62 miles round trip per millisecond. In short, it takes time to cross significant distances, and these latencies will add up. Each individual hop or router can also impact performance, as each one is a chance for congestion, jitter, or even packet loss. So really, with Global Accelerator, we are ensuring that users' traffic enter AWS broader network much closer to them than it previously did. Less networks mean less kilometers of cable to travel through, and less router means less chances for congestion, jitter, and packet loss. This eliminates a lot of the internet fluctuations effect on users' experience. We have third-party monitoring tools deployed globally to measure the performance of real traffic that flows through Amazon Global Accelerator. We have seen very significant improvement in terms of first byte latency, throughput, and network jitter when you serve your application through Global Accelerator. For use cases like gaming and telecom customers, it is very important to have stable internet. And as you can see in the graph here, the green line represents much lower and stable network latencies for traffic that's served through AWS Global Accelerator as opposed to the open internet. You can go to the website provided in this slide to measure speed improvement by connecting to Global Accelerator and just test how much of an improvement you can see on your device. Alright, so we just went through AWS Edge networking services that improve performance and availability of your application. Now, we will talk about how Edge services can help you improve your overall security posture of your architecture. So let's talk about application security. CloudFront provides a robust suite of security features that are both natively built into our service's DNA or is optionally configured depending on your individual use case or need. For example, SSL session tickets. As part of the SSL handshake process, the client and the server exchange multiple packets as part of a negotiation ritual that results in agreement to use a particular encryption model and a certificate. This process entails multiple round trips and a fair amount of computation on both ends, like server and client, which adds some latency to the connection process. To avoid some of this business while keeping the connection secure, CloudFront now implements SSL session tickets. And note that the process has to be repeated if the connection is broken. So using SSL session tickets, really, what happens is after the TLS negotiation is completed, the SSL server creates an encrypted session ticket and returns it to the client. Later, the client can present this ticket to the server as an alternative to a full negotiation and when resuming or restarting the connection. And this ticket reminds the server of what they have already agreed to as part of the earlier SSL handshake process. So it really improves your SSL connection. With CloudFront, you get most advanced ciphers and TLS versions like 1.3 by default. CloudFront allows you to deploy an SSL certificate for free via Amazon Certificate Manager. This allows you to start serving your content over HTTPS within a matter of minutes. CloudFront also supports Perfect Forward Secrecy. Perfect Forward Secrecy creates a new private key for each SSL session. In an event that a private key for a session was discovered, it could only be used to decode that session and no other sessions will be decoded using that key. So it just improves overall security of your SSL. CloudFront now supports a set of advanced RSA AES ciphers. The server and the client agree on a ciphers automatically as part of the SSL handshake process. So you as a user do not have to do anything additional to support this. Access control security features with CloudFront allow you to block content based on geo and allows you to restrict premium content and secure content. So CloudFront provides advanced options to encrypt your content. For example, field level encryption. Using field level encryption, you can encrypt select data of your payload, for example, credit card and mobile numbers for some security sensitive workloads. So when you use CloudFront to terminate your SSL connections, you get to take the advantage of TLS version 1.3, which is powered by S2N. S2N is a new open source SSL implementation developed by Amazon. Traditionally, OpenSSL has been the de facto reference implementation for SSL libraries. The thing with OpenSSL though is that it contains more than 500,000 lines of code, with at least 70,000 of those involved in processing TLS. Naturally, with each line of code, there is a risk of error, but this large size also presents challenges for code audits, security reviews, performance, and efficiency. In order to simplify our TLS implementation and to provide the most advanced security features, we have launched S2N. S2N has been designed to be small, fast, and with simplicity as a priority. S2N avoids implementing rarely used options and extensions, and today is just more than 6,000 lines of code. As a result of this, we have found that it is easier to review S2N. We have already completed 3 external security evaluation and penetration tests on S2N, a practice that we will be continuing. So many customers that distribute content over the internet want to restrict access to documents, business data, media streams, or content that is intended for selected users. For example, users who have paid a fee. Using public-private key encryption algorithm, you can sign your requests to be served only to authorized users. You can set an expiration time for how long these URLs should be valid for. Alright, let's now take a look at our edge networking security services that help us with perimeter protection to prevent external threats such as DDoS attacks, bots, and application attacks. Internet infrastructures are always getting attacked by different malicious factors. I wanted to talk about some common threats we see for different workloads and what we can do to protect against these threats on AWS. In SYNFlood, attacker sends a succession of SYN requests in an attempt to consume enough server resources to make the system unresponsive to legitimate traffic. In reflection attacks, the attacker exploits vulnerabilities in DNS servers to turn initially small queries into much larger payloads. Web request floods on the other hand, are sophisticated layer 7 attacks where excessive requests that look legitimate hit your application. So also want to talk about application-specific threats. These threat exploits can be targeted for your application code, for example, SQL injection, or it can exploit your underlying platform, for example, Apache or Tomcat. So finally, bad bots are notorious for crawling to scrap content such as web assets and catalog. For example, price, it could be product images, or it could be something that's behind your paywall. So how do we protect against these external threats? Let's look at AWS perimeter protection services that can help us with that. So first, I want to talk about Shield Advanced. Shield Advanced is a managed threat protection service. If you want one solution to outsource all of your threat protection, AWS Shield Advanced is the option. With Shield Advanced, you get comprehensive support to prevent infrastructure layer attacks as well as more sophisticated layer 7 attacks. Shield Advanced includes DDoS protection designed to help keep customers' applications online and healthy. Shield Advanced offers 24/7 access to Shield Response Team. The Shield Response Team is a group of security experts that handle responding to and mitigating DDoS attacks for AWS customers subscribed to Shield Advanced. They have deep expertise around DDoS attack response, including analyzing sophisticated unique attacks and quickly developing mitigations. AWS Shield offers Layer 7 anomaly detection using AWS WAF. Using AWS WAF, AWS Shield gets deep insights into the volume and composition of normal web traffic specific to your application. When a deviation from that baseline is seen, a DDoS attack is detected and details of the attack is shown in the Shield Advanced dashboard, and you can also get notified via CloudWatch alerts. Alright, AWS WAF. So really one-liner for AWS WAF is that is a layer 7 firewall that can be integrated with your AWS services. With AWS WAF, you complement your application layer level security such as route tables, security groups, IP tables, and such to have a comprehensive cloud security. AWS WAF provides frictionless setup so that you can deploy it without changing your existing infrastructure. It provides low operation overhead because it has ready-to-use built-in managed rule sets from AWS and other well-known vendors via AWS Marketplace. AWS WAF offers highly flexible rule engine that you can inspect requests under single-digit millisecond latency. And lastly, AWS's WAF's API-driven architecture and fast rule propagation allows you to detect and respond to threats in real time. So I talked about AWS Managed Rule Sets a bit. The idea behind AWS Managed Rule Set is that we would cover the common attack vectors so that you don't have to spend a lot of time managing basic set of rules. So we provide you with a stable baseline to work with. These rules are managed by our threat research team, which is an extension to our DDoS response team from AWS Shield Advanced. These rules are primarily influenced by top 10 security risk identified by OWASP community. And one really cool thing about AWS Managed Rule Set is that you can use that at no extra cost. So I mentioned that we have extensive rule engine that allows you to inspect any part of the request using AWS WAF. The rule engine is documented based format in JSON, meaning you can actually represent all of your rules in a code format, and you can copy and paste it to other WAF rules if you are managing multiple accounts. You can write rules such as regex expression, string match, and size or length match to look for specific pattern and to block the traffic out. You can also use IP match, rate limiting rule, and geographic match to filter out requests from a specific type of users. AWS WAF is a self-service model service that you can configure so that you can configure everything by yourself, and which makes it easy to use and manage AWS WAF because you can maintain your own rules. All right, so last service that I want to talk about under AWS's Edge Services Perimeter Protection Suite is AWS Firewall Manager. Firewall Manager is a security management service that helps you centrally configure and manage your firewall policies across your accounts and applications in your AWS organizations. So AWS WAF today supports AWS Firewall Manager today supports AWS WAF, Shield Advanced, and security groups for your VPCs. The Firewall Manager simplifies management of WAF rules because it is integrated with AWS organization. You can have Firewall Manager access all of your WAFs and your security groups under different accounts in one organization. It ensures compliance for your organization, making sure that mandatory set of rules are applied and followed by your individual account owners. It automatically applies remediation even when there is a new account or a resource added that is not compliant with your organization-wide policy. It provides visibility across organization, giving you that single pane of glass for looking at threats across organization, but at the same time giving you granular access at the account level. So Firewall Manager has integration with AWS Security Hub. It allows you to see any new event generated that requires your attention through the Security Hub console. You can use a centralized dashboard to see what new resources are not compliant with your org-wide policy. And for example, if an individual account owner added a new load balancer or a CloudFront distribution and did not apply a recommended rule, you will get notified that, hey, there is a rule missing. Or you can set up your Firewall Manager so that you can auto-remediate that action. All right, so now let's look at how we can use all these services that we discussed to create a scalable and secure architectures for some well-known use cases. Okay, so this is a common architecture for serving video on demand application. Like in any video streaming service, your first step as a user is to log into your account. This step here is represented here via the red arrows. The authorization and authentication mechanism is configured using Lambda at the edge and Cognito in the viewer request event of CloudFront. Now, offloading this authentication step to the edge closer to the users has a few benefits. For example, it reduces load on your origin and it improves performance of your application because now the authentication is happening much closer to your users. So the next step is that after the user has been authenticated, they then start streaming their videos. That streaming video step here is represented via orange arrows. As you can see in the architecture, the first line of defense is provided by AWS WAF and Shield. These two services work together to protect your system against any external threats. We are also using Lambda at the edge on the CloudFront origin request trigger to perform URL manipulation to obfuscate the internal directory structure of your media origin. And lastly, CloudFront is being used to cache content, your videos, to your users to provide best performance possible. And we are, as an origin, we are using Media Package as a just-in-time packaging service to serve videos that are specific to your client's requirements of bitrate or a device type. It could be a mobile device, it could be a laptop, and we are delivering videos according to those device types. Okay, so let's take a look at how Global Accelerator can be used to accelerate traffic for multiplayer game. You can use Global Accelerator's custom routing feature to send a similar group of players to a single backend instance. So what happens without custom routing is that, let's say, for example, users in Berlin will get routed to a backend instance in Frankfurt, and a similar user from Helsinki will get routed to an instance in Dublin. But with custom routing, you can map traffic coming to a specific port from a similar set of players on Global Accelerator to a single instance, which is the single backend instance running behind your Global Accelerator. That improves stickiness and user experience. So by using Global Accelerator, you can improve the gaming experience by reducing lag and packet loss. You can scale your game globally to markets with minimum infrastructure deployment. Since AWS Global Accelerator is a managed service, you can simplify your game fleet deployment and reduce costs. Finally, with custom routing, now send group of players that are matched together through Global Accelerator to the same destination. Lastly, I wanted to talk about protecting your on-prem applications in a hybrid environment where some of your data might still live in your on-prem data centers. So you can use the scale of Route 53 and CloudFront to route your traffic to on-prem resources. You can place CloudFront in front of an on-prem application and only allow CloudFront IP addresses to talk to your data centers for improved security. So this gives you the same protection that CloudFront provides without you having to change your on-prem architecture and your configuration in your origin. It is also possible to route traffic to application load balancers or network load balancers and then target your on-prem resources using Transit Gateway or Direct Connect. All right, so we talked about AWS Edge Networking Services and Perimeter Protection Services, and now how can we use them to improve our application performance and security? We looked at some of the common architectures used in production. So what's next? You can review the services in more details and look at some reference blogs to get started with integrating AWS Edge Networking Services to your applications. We have lots of training and certifications available to learn more about AWS, so make sure to check it out. All right, and so thank you for joining this session, and I hope you enjoyed it. And one last thing before I let you go, please remember to take the survey so that we get better data points on our side. Thank you.